Hey everybody, this is Larry. This is day 15 of the September Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this forum. And this video is coming out a little bit late, so you've probably already seen, or maybe if you were looking for it, you'll see my other video. My apologies. I've been getting injured a bit lately, on the hamstring, and I've been just going to rehab and physical therapy and all these things. So a little bit tired, a little bit busy, but let's get this done today. 1584, min cost to connect all points. So you're given points to the plane at their Manhattan distance, and you have to connect all points. There should be just minimum spanning tree, right? I mean, when yeah, if you want to just connect all points, then yeah, it's just gonna be minimum spanning tree. I was gonna say, like, you have to kind of be really careful about how they, phrase the problem, but you can see that this is a tree. And minimum spanning tree, there are a number of different algorithms. Probably not gonna go over all of them today, just because, well, am I spelling this right? That's definitely not right. Cusco. Man, what am I thinking of? Cusco. Yeah, that's definitely one. There's no H. I don't know. I tell you. There's frames, and a couple, and then there are like some higher intensity ones. But those are probably the only ones you need. The core part about understanding minimum spanning trees is that it is a greedy solution. And once you realize that it is greedy, it really doesn't matter. Like you could probably rederive both Prim's and Cusco's, just from that observation itself. That said, MST don't really come up that much on either interviews or competitive super much that I can aware of. The only kink in this one is that it is Manhattan distance, in case you wanted to care about. Yeah, I think that's it really. Yeah, I mean, I think you could certainly do Cusco's, but today I think I'm going to just do Prim's, because I feel like I haven't done that in a long time in general. I'm going to at this point I'm going to cheat and take a look to see what I did previously, so I could do the other one. If I lied and did Prim's recently, then this is just Cusco with the union fine, and this is also Cusco. Yeah, let's do Prim's because I feel like that doesn't really come up that much, given that. So one thing to note is that depending on how you construct the graph, and certainly you could construct it implicitly or explicitly, so there are some nuances with that one. Prim's is actually better for a dense graph, because get min is only O of n instead of, and so it becomes n square or v square, and v square of course is O of y, so you don't have to sort yi log yi or something like this. I don't know if I did it. I mean, I don't know why I didn't do it last time, but let's play around with Prim's algorithm. So yeah, so basically, we don't have to sort anything, right? So yeah, all pairs are distinct. So okay. So total is equal to 0, right? And then we just take a random point, which is the first one, I suppose. So for let's just say n is equal to length of points, right? Yeah, okay. I'm just trying to think about the cleanest way to do it. And of course, but the idea is that at every point for Prim's, you get the minimum, you get the node that's the closest to your existing tree. Like I said, greedy. So very easy to kind of come up with. But of course, then, so my dot, and I'm just going over, like, because I think one thing that people, and I don't know if I'm giving the wrong impression of sometimes, is that I have all this memorized and so forth. But for me, it actually is, I probably could articulate it a little bit more, is that I actually was coming up with that from scratch, meaning that, okay, now I have prim's algorithm as I'm doing prims, and the idea is that I'm greeting on the node, which means that I get the next node, right? And of course, if you do it naively, you know, you have existing k nodes in the tree, and you're trying to get the minimum distance. If you do some k times n thing, obviously it's going to be n cubed and too slow. So now I was like, oh wait, no, you just do an update thing. So I was able to kind of prove, if not, maybe not prove, but at least come up with all that pretty much within the time span that you see me at, so like a couple of minutes. So, you know, like I said, these things, as long as you kind of really understand the problem or the algorithm, it's not that big of a deal. So yeah, so basically, yeah, we constructed distances of infinity times n, right? And infinity is going to be some big number. And then here we set it. We set the first node, right? So for I in range of n, actually we don't even have to do that, I guess. Like I said, I'm I don't know, I'm doing a weird way. Like I'm coming up with this kind of from scratch, right? So yeah, we haven't done this in a long time. I don't even remember the last time I've done this. What is one? Yeah, so so then now we just have to relax n nodes because we want to add all of them. So we do it one at a time. And then basically we have a get min function, right? Say. And then we have an update function, right? And that's basically really it. We update min, index, maybe index and d for distance, and then total we add it to d, and then that's pretty much it. I mean, well, it's pretty much it except for these magic functions. But yeah, get min is for I in range of n. We want to get the min that is not done, so actually I have to add in like a just call it done maybe. So if this is not done, so we have some min distance is equal to infinity, and min index is, I don't know, -1, right? So then if this is not done, then if distances of I is greater than min distance, then yeah, the min distance is equal to distances of I, and then min index is equal to I, right? And then we just return min index, min distance. That's a tuple. I think I don't need the explicit tuple, but I don't know, I'm more comfortable about it. And then, yeah, and then that will give us the min thing, and then update min. Maybe I need to update index actually, so I lied. So update min with this index, and then basically, what am I doing? Yeah, and basically this is just updating the distance. So now we set done of index is equal to true, and then for I in range of n, if not done of I, and if it's done, it wouldn't update anyway, because that's how greedy works. And the distances of I is greater than if this distance is greater than the so we're updating it for points of y, so let's just call it some calculate distance from I to index, right? Then distances I is equal to maybe we can also use what you might call it, the walrus operator here to save one calculation, but I'm a little bit lazy, and this should be a cheap calculation, right? So it's fine. From say index A and index B, and that's just you know, the Manhattan distance, right? And of course you need to absolute value this. I kind of wrote it in a weird way. That should be good if we were right. But instead we return, why do we return D? I meant total. So D we add, did I miss something? It's possible. No, oh yeah, min distance, this should be smaller. Whoops. Easy fix. And yeah, and there you go. Am I good to submit? Did I miss any weird edge cases? Maybe, but I think it's still good to submit as long as it doesn't time out. Yeah. So, I mean, one thing that and maybe I overemphasized this a little bit, but I'm still gonna do it again anyway, one more time, which is that, I rail a lot about memorization and memorizing things, and for this particular problem, would have probably been fine, but at least for me, I don't know, maybe you have a great memory and stuff like this. I'm old, and my memory is getting poor, to be honest. So I can't remember everything, but once you understand and figure out how to learn, and that part is kind of tricky because I can't really teach anyone to learn per se because everyone is unique in that way, and also everyone's unique and everyone has certain triggers and things that they are better at, right? So but all I can do is kind of show you different ideas, show you different possibilities, and for this, like I said, like once you realize that the problem is going to be greedy, and then another way to think about it is that Cusco is greedy on the edges. You just keep on adding edges to the tree as long as you can with greedy, and Prims is adding nodes to the tree as close as you can every time. And so you could write this, you saw me writing it, even though I still made a silly typo bit. But yeah, and I think one thing that you can also note is that in the past, this is yi log yi because we do Cuscos, right? Because we have to sort the edges. Particularly in this case, I don't know why I didn't do it before, even though I even mentioned it here. Oh, wait, no, I lied. I didn't mention it here. But you can notice that the way that I, at least today, thought about it is that it's a dense graph. In fact, it's a n square graph, right? Meaning, in theory, if you want to write it that way, maybe there's some kind of like you could probably play around with fake edges or something like this if you really want to with Cusco, and that would be maybe interesting with relaxing. But I think that's still, maybe that's slightly faster, but because then now you have a log re factor instead of log yi factor, but that's only twice as fast. Where here you just get rid of the log factor altogether, right? So yeah, and you could even get min in a. Can you do get min? Well, you could do get min in a obviously quicker way, but I think update min you need to. Maybe I'm wrong on that one. I haven't really looked up in. I feel like this is one of those like crazy Fibonacci heap things that people always talk about. But it's been a while, so I don't know. I don't remember all the literature, but I just remember how the the idea goes. Anyway, so what's the complexity here? Just to kind of clear it up, is that this is going to be re square or n square or re square, where this is a loop of re, get minus O of n, update minus O of n, and that's a easy n square time, and solution or space, you have 2 O of n arrays. So this is O of n space and linear space. That's all I have for this one. Let me know what you think. Let me know if you did it this way with Prims, because I feel like, at least on my, I don't know, just taking a quick look on my Discord, it seems like many people did it with Cuscos, but maybe I'm, I did this a little bit later, so maybe I am lying. Yeah, which is actually kind of amusing, but. Oh, actually, someone did do it with Prims, but actually, I guess they did it both ways. So yeah. Anyway, I don't know. That's all I have for this one. Let me know what you think. Have a great weekend, everybody. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.